Hello guys, my name is Engineer Alige. You are welcome to this particular video. Now we want to solve question on the re-jam mock. We have several students, I have a lot of numerous students. They send different videos to me concerning the just concluded 2025 mock exam, and we'll be looking at them as far, although we don't have everything, but at least based on the number of questions sent to me, and we should have about 95% or 98%. Now, what do we do? First question is that what they say, the graphical representation of effect of temperature on a saturated vapor pressure of a liquid. What they are trying to say is that when you plot the graph of temperature against, or saturated vapor pressure against temperature, SVP against temperature. Now, first of all, we must know that the SVP, saturated vapor pressure, is when it's achieved when the molecules that are going out, when you heat a substance, and the number of molecules going out is equal to the number of molecules returning back to the liquid. Therefore, we say it has attained the level of saturation. That means that when you boil a substance, a liquid for instance, and the number of molecules that are going out from that liquid is equal to the number of molecules returning, we say it has attained saturation. Now, saturated vapor pressure depends on temperature. It's another temperature. Although their relationship is not linear, let's take note of that. Their relationship is not linear. So when we say SVP is proportional to what? Temperature. But not linear. Not what? But non-linear. Now, so the graph, when you plot the graph is proportional, but it's non-linear. So that is to say, the better graph for that effect is what? Option A. And note that what saturated vapor pressure, what SVP does not what depend on what? Depends on pressure or volume, as the case may be. So that is just that. Does not depend on what? Volume or pressure, but depend only on what? Temperature. Now that is answer. So we go for option A. Let's go to number 2 now. He said a gardener pushes a lawn roller through a distance. Now, when we are solving calculation in physics, that number 2 now, we have solved number 1. So number 1 is option A. So when you want to solve question on calculation, or we want to solve problem involving calculation in physics, number 1 thing you must know is your data. You take your data, your suitable formula, then you take your word, solve. So in that regard, I will take it as what? DSS. So you take your data. Now what is data? They said what? It pushes what? The lawn roller, pushes what? The gardener pushes what? The lawn roller through a distance of D is equals to what? 40 meter. If she applies a force of what? Now that means that thing is given as mass. So let's convert to force. So we know that force equals to mg. So in that case, we are going to have 40 times 10. They give us 400 Newton, because what they give to us is in what? In mass. So we convert to weight. Then I see what? She applies a force of 400 Newton weight in a direction inclined. That means that, look at it, what he applied on the lawn roller, let's say this lawn roller, he applied 400 Newton at what angle? At an angle of 60 degrees. So to move it a distance of 40 meters. So that is what have just happened now. To move it a distance of what? 40 meters. Now what do we want to calculate now? Work done. We are looking for work done. Because they say calculate the work done. They say move me inclined at an angle of 60 degrees to the what? To the horizontal. So this is the horizontal. Now what do we do now? We just use our formula. We resolve this 400 along the horizontal. So if you resolve it according to vector, here will not be what? Since it's inclined to the horizontal. Here will now be 400 cos 60 degree. And if that 400 cos 60 degree, we are going to have what 400 cos 60 degree, which is a force, times what is the distance moved. He moved it what 40 meter. So what I'm going to do now is 400 cos 60 is half. So 400 times half times 40. So we are going to have what 8,000 joules. So that should be what option what A. So option A is our answer for number 2. And the number 3 says the primary color are dash. Now for me to answer this question, let me give you this shortcut, which I call what? We call it the dry, brim, and whisk. We call it what? The dry, the brim, and whisk. What does that mean? It means green plus red, we produce what? Yellow. Yes. Then blue plus what? Blue plus red give us what? Magenta. Then we now have what? Green plus blue give us cyan. So please take note of that. Dry, brim, and whisk. Dry, brim, and whisk. So it's just a way of remembering, just like a memory kind of reminder. So to make you know that green plus red give us yellow, blue plus red give us magenta, then green plus what? Blue will give us what? Cyan. Now most of the times our primary color are the red, those one here that will mix together. Don't forget they are spotlight color. They are not paint. If you mix paint together, all these 3 colors, it cannot give us white. But in physics, we understand that red plus blue plus what? Plus green will give us white. That means spotlight colors, like non-white, white lights, give us white light or white. So, but as it paints, so it cannot work that way. So when you mix red paint plus blue paint plus green paint, you now have white. It's not possible. What you go to have probably within brown color thereabout. So, but that is not where we are going. So our answer to this question is what? The blue, green, and yellow. So these are the primary color. But if I want to ask what are the secondary color here, the secondary color are what? The magenta secondary colors. So the secondary colors are what? Magenta, cyan, and yellow. These are the 3 secondary colors that we have basically. Now the next one says that what? Number 4 now. He said all heat. So the answer is D. Option D. He said what? Number 4 says what? All the heat generated by current. That means current, this current, all the heat generated, let's say I equals to what? 4 ampere. Passing through. So they said what? Passing through this. Now, but please, we made mistake here. I'm choosing what? Red, blue, and green, but I choose the wrong option. So it should be what? Option C. So option C. So please, sorry for that. Now let's go with that. See what? For all the heat generated by current 4 ampere passing through a 6 ohm resistor. So the resistor is what? 6 ohms. For 15 seconds. That means for 15 seconds. Time is 15 seconds. Now what this we should find for 15 seconds is used to evaporate what? 0.01 kilogram. The mass to evaporate. That means just to evaporate. To evaporate means to turn it, to give it a latent heat of vaporization of the what they say 0.01 kilogram of liquid at its boiling point. Okay, what they say we should find. Say what is the specific latent heat of the liquid. That means what they are looking for now is specific latent heat of vaporization. Now, what I understand concerning this question is that the heat produced as a result of passing current of 4 ampere having a resistance of this hour for these seconds helps to just what? Evaporate the liquid. So in that case, the heat would supply to evaporate. You understand? That means that heat energy is what is the heat energy formula? The heat energy formula is for I square RT, or what we call V square R times T, or we call it what? ITV, or I square RT, or IVT. So this is heat energy. Now, another thing again I want you to understand here is that for us to what? To evaporate this, there is an energy that is applied to it. And that energy, we have solved this question. Please permit me to clear this so that we can have more space. The energy that is applied to it is what? What? Heat due to latent heat, just to change the state of the body from was liquid to vapor. And that will be what? ML for vaporization, MLV. So this one is the mass translating it of what? Of what? Of the liquid that we have evaporated. Now vaporization. So we are now going to equate the two of them. This is for the liquid and this is for the heat. So I'm going to say the heat energy is equal to what? The heat due to the liquid now to evaporate the liquid, which is L. So we are going to have it as what? I squared R T equals to ML. Now let's substitute the value there. We are looking for LV now. So what I want to have now is that I want to put our value there, which is what? 4 squared times, what is our R? Our R is 6 ohms, which is 6 times 15 equals to what? What do we have as our mass is what? 0.01 L what? V. Now this one will give us 16 times what? 6 times 50 equals to 0.01 LV. If you press your calculator, this one should be giving us 1440, because this is 96. 96 times 15 should give us 345 plus what? 6 with 154. Then carry 5, what? 1440 equal to 0.01 LF, what? LV. Now, how do we do that? Now, to make LV solid of 1440 divided by what? 0.01. So what do we have? I would have 144,000. Press your calculator. Joules per kilogram. So that means if you check it, 1, 2, 3, 4, 5. So I will have it as 1.4 times 10 raised to the power of 5 joules per kilogram. And which option is that for that question? 1.44 times 10. We can go with B. Option B is 1.4. Approximately is 1.4 actually. So to 1 decimal place in standard form. So that is just that clear. Now option D is B is the answer. Now let's go to the second one, which is number 5. Number 5 is another question that has to do with thermal conductivity and all that. And we all understand that the rate of heat supply to a body, let me clear this part. The rate of heat supply to a body is equal to the what? The thermal conductivity times area times temperature gradient. That means what I'm saying now is that what? The rate of heat, that means heat over time, is equals to what? That means heat over time is equals to K times A times temperature gradient over L. That is the formula. Sometimes we have it as minus depending on if what the change in temperature gives negative. Now, this is the formula we want to use now to solve this problem, because without formula you cannot solve. Now they say 288 kilojoules. That is heat. The heat is what? 288 kilojoules. Kilo means what? 288,000 joules is conducted across opposite faces of 3 meter cube. That means area of that cube, area of cube will be equal to what? What is area of cube? Length L square, which is that's 3 times 3, which is equal to 9 meters square. That's area of, we need the area. A temperature gradient of this temperature gradient, this is what we call the temperature gradient. Temperature gradient is equal to what? Change in temperature over length. That's why the unit is always what? Per degree Celsius per meter. Because this one is measured in degree Celsius, this one is measured in meter. So that's why if you check the unit itself, you see now that the unit is what? This is not 90 degree, oh, is 90 degrees Celsius per meter. So and that is giving us what is the value given to us there? 7200 what? No, they give us 90 degree per centimeter. Then what again I will give you? We are giving time. They said in how many seconds does it take to do that? Then the time taking to do that was what? T equal to 7200 seconds. Now we have gotten all our parameter. What they say we should find now? Calculate K is thermal conductivity we are looking for. So for us to find thermal conductivity, we have to what? Put all our parameters. We have taken our data. The suitable formula is set. You understand? And so we can now what? Substitute our value and get our value answer. So we do that accordingly. We are going to have what? 288,000 over 7200 is equal to what? K times what? 9 times what? This one is given as what? 90. So I don't think we have any other thing now. Together is given as 90, so we're looking for K. So what we're going to do now is that this one will cancel this will cancel this. So I'm going to have left with what? 2880 over 72 equals to what? This one will give us what? K over what? Now let's say times, okay, let me even divide both sides by what? Well, let me leave it like that first. 9 times 90. Now, if I divide both sides by what? By 9 times 90, I would have K equal to what? 2880 over 72 times 9 times 90 is what I want to have. So this one will give us what? This one will cancel this one. Okay. Then this one now we can divide it by what? By it's divisible by 3. And so 3 here is 3. 3 here in is what? 9. The remainder 1 in what? 18 is what? 3 is your 6. 96. Then we can have 3 again. 1. 3 here we are going to have what? As 32. Then let's say 2 here we are going to have 36. Then 2 here we are going to have 16. Then I think we can go further by saying 4 here we are going to have 4, and 4 here we are going to have 9. So 4 over 9. We have another 9 here, although that one now we are. Then don't forget that there is an what? We can divide this one and see what? 4 over what is remaining here is what? 81. 81. So if you press our calculator very well and do our division, we are supposed to have 1. That means I want to have this answer, which is about let us press our calculator to be sure. So if you press our calculator there, you are going to be having a 4.9 times 10 to the power minus 2. 4.9. And press your calculator. Everything will be 4.9 times 10 to the power minus 2. That's it. Then you need to know what? 4.9 times 10 to the power minus 2 watt per meter per Kelvin. So that is what option what? B. 4.9. Can press your calculator to confirm. You understand? If you do that accordingly, that's what I would have. That's what I would have. If you follow it one after the other, because you know that in 72 that is meaning at 2880 divided by what? 72 times 9 times 90, which is what? Then if you do it now, you see that this one will cancel this one. Then 3 can go in this one, will give us what? 9, because 3 times 9 is 27. Then you now what? You add 1 to you at 96. So if you do that, maybe like 3 year, you are going to have it as what? 24. Then 3 year, we have 32. Then you can see 4 year, you're going to have 8, 4 year, you're going to have 6. At the end of the day, you're going to have 2 year 3, 2 year 4. So I want to have 4 over, let's say 981. 81 times 3 is what? 3243. So I will have 0.0. Then this one divided by this one, I'm going to have it as maybe like can anything divide? Let me even see whether anything can divide it. Okay. 72, 96. Just carry your calculator and divide so that you'll get your answer. Now let's go on. So I don't want to waste time there. Now, the next thing we're going to solve now is the range. Although when you have got it to this point, your calculator and your system can do the remaining one. So you don't need to waste your time there. So you can just carry your calculator and so. So you calculate the range of the body projected with a velocity of what? 30 meters per second at an angle of 15 degrees. So that is to say that what? The range formula, don't forget the range formula is equal to what? U square sine 2 theta over g. Don't forget time of flight is equal to 2u sine theta over g. We have maximum height is equal to u square sine square theta over 2g. We have a time to reach maximum height is equal to what? U sine theta over g. All these ones are normal formula, but all these formulas are applied or applicable to what? A body projected from the ground level and come back to the ground level. That is the basic concept about this formula. If not, it will not be applicable to any other condition. Now let's solve. To solve our range, our theta, they give us u initial velocity of projection as what? The velocity of projection as what? 30 meters per second, which is velocity at which they project the body. And at an angle of what? Angle of 15 degrees to the what? To the horizontal, which is given to us to the horizontal. They say g as 10 meters per second square. They are also giving what? Theta as 15. So what we want to do now, we just find our range now to what? 30 square, we give it sine 2 times 15 over 10. So then this one will give us 900 times, this 2 times 15 is 30, sine 30 over 10. This one will cancel this one. The sine 30 is what? 45, and it's 1 over 2. So I would have what? 25 meters as our range formula value. So the answer is option B. So please don't forget that in your Jamb there is no calculator that can press sine 30. So all this you should know them without your pressing calculator. Hello guys, we are in number 7, and this one says turning fork of frequency 176 Hz and 180 Hz are sounded close to each other. So what is the frequency of the beat? Now beat frequency is what? Beat frequency is F2 minus F1, or rather F1 minus F2 absolute. So just take the bigger one or smaller, because when you take absolute, mean that you cannot have negative sign. So in that case now you can say 180 minus 176 Hz will give us what? 180 minus 176 will give what? 4 Hz. Even if you say 176 minus 180, because of this absolute, any minus that comes in, this symbol, this sign mean absolute, always turn it to plus. So our answer is what? Option A. Now they say the weight of an object can be determined by what? A beam balance is used to determine mass. So using the principle of moment. A lever balance, same thing. A spring balance is used to determine weight using what they call Hooke's law principle. So I will go for Hooke's. Don't forget, vernier caliper is used to measure length to two des was in centimeter. In what 2 centimeter, that means 2 decimal places in centimeter. That is vernier caliper, and we use it to measure curvilinear object like internally or externally, like internal diameter of a test tube to bottleneck of a merinda, the diameter of a rod and all that. But when you are using micrometer screw gauge, don't forget, micrometer screw gauge, you use pointed object to measure pointed object like very thin, small or pointed object. For example, the diameter of a needle, diameter of a thin rod can be measured with any micrometer screw gauge. Please take note of that. But if they see my diameter of a rod, vernier caliper, diameter of a thin rod, you use micrometer screw gauge. What about diameter of a ball bearing? You use vernier caliper. What about diameter of a small ball? You use what? Micrometer screw gauge. And micrometer screw gauge measure to what? To 3 decimal place in centimeter. We have vernier meter rule, which is used to measure laboratory equipment like measurement of length of a book and all that. Now, measuring the length of a book is different from measuring the thickness of a paper. To measure the thickness of a paper, of a piece of paper, you use what? Micrometer scale. But to measure the length, you use meter rule. So that one is solved with spring balance. Don't forget, spring balance also uses Hooke's law, and it's a function of gravity. This one, beam balance is a function of what? Matter. This one can change from one place to another, but this one measurement does not change. It remains constant from one planet to another, from one place to another. Let's go to the next one, number 9. The velocity ratio of an inclined plane, the velocity ratio of inclined plane at 60 degrees to the horizontal is dash. Now the velocity ratio formula, velocity ratio is equal to 1 over sine theta for an inclined plane. For inclined plane. So if you know the formula, it is already solved. What they gave us theta to 60. So I will have that 1 over sine 60, which will give us 1 over square root of what? Over 2. And this is what? 2 over root 3. Don't forget that this one is theta root 3 over root 3 if you rationalize. And that will give us what? Because you cannot, if this one go up now, you cannot leave root 3 down, so you have to rationalize. We have 2 root 3 over what? Over 3. Root 3 times root 3 will give us what? Ordinary 3. Don't forget that this one is 2 times what? 1.731 over what? 3, which will give us what? 2, 6, 14, carry 1, 2, 3.4, which is what? Divided by 3. And that will give us approximately 1.55, 1.155 approximately if you press your calculator. Because 1 divided by this 1 in 4 is 1, carry 1. The 15, 5. Your light soon as well. So that one is settled. Now let's go to the next one. Let's say the focal length of objective lens of a telescope is 100 centimeter. If the angular magnification of the telescope is 50, what is the focal length of the eyepiece lens? Now don't forget the shortcut. For telescope, we have what they call TOS. TOS. Now what does that TOS indicate? It's a shortcut acronym to remember something. Let me show you. Now what does it mean? It means that what for all telescope, their what? Objective lens is what? Objective lens is longer, while the what? The eyepiece lens is what? Shorter. So that means that for all telescopes, now they have longer objective lens and shorter eyepiece lens. So that means that their f naught is always greater than what? Their fe. Now don't also forget that what? The magnification of what? Of a what telescope is equal to f naught over fe minus there indicate inverted image. So when the image is inverted, you have that. Don't forget for astronomical telescope, they are produced by two lenses, which is two convex lenses, and their final image is always what? Inverted. Although abnormal adjustment, the distance between what? The two what? Mirror, the two lenses involved is equal to what? F naught plus Fe. Because when they are what? They are used to take image from a far distance, we understand that what? The image will now be formed at a point between the what? So this one will now send it back to what? Send it what? To the infinity. So this is how it works. That means we use what? Telescope to measure far distance object like the sun, the stars, and the moon. So that means that this one is what we call abnormal adjustment. Why? Because the F naught from here to this place is equal to what? Fe from here to this place. So this is what we call what? A telescope. Now this is the objective lens and this is the eyepiece lens where eye will be placed here. So this is a what? An astronomical telescope abnormal adjustment. So that's how I say the distance between them is what? F naught plus what? Fe from here to here. But don't forget the image. The disadvantage of using this microscope or telescope is that it produces what? Inverted image, and it's a disadvantage to the earth, though it has a better magnification. But to improve on them, we use what they call Galilean telescope. We use Galilean telescope. Galilean telescope. Now this one is what? Astronomical telescope. In Galilean telescope, the instrument uses what? One convex lens and one concave lens. In Galilean telescope, the instrument uses one concave lens and one convex lens, meaning that the final image at the end of the day produces what? An erect image. This is a rough sketch of how it work. So it carry the image from infinity and produce it what? Like this. So the image will now be sent to what? Like this to infinity. So the image will now be produced. Now if you check from here to here is Fe, while from here to here is F naught. From here to this place is F naught. So that means from here to this place is F naught. Now what we are now saying that from here to this place now it now be F naught minus what? Fe to get from here to here. So you see that it has a what? A smaller view. You understand that compared to this one, although the image is what? Erect, finally erect, so which is used for terrestrial what? Telescope. But we have a better telescope which you call what? A terrestrial telescope, which uses what? Three what? Lenses. A terrestrial telescope uses what? Lenses. We have terrestrial telescope uses three lenses. One is for what? Erecting lens. The other one is to take image, and the final image will be erect. Now I don't have time to explain that, but watch our video more to get more, because this is just a solution. But let's solve the question. F naught over Fe is equal to magnification. So let's solve now. What is angular magnification? Now we are giving as what? 100 what? No, we are giving as 50. So what is the objective lens? We are giving 100 cm over Fe. So if I want to solve now, I will now what? Divide both sides by or cross multiply. As the case may be, we have 50 Fe equals to 100. So Fe now be 100 divided by what? 50. So the answer will be what? 2 centimeter. So this is the answer. But we are going to create a class where we talked about the what? The optical instrument and talk about a lot of things about this particular telescope. Thank you.